This will be a demonstration on how to build the lamp base for the Rapid Prototyping Workshop project. And it's going to be done in Tinkercad. And it is not going to be a tutorial in Tinkercad. It sort of assumes you already know how to do the basics in Tinkercad. It's just going to walk you through the steps. So I've opened a project here. We can zoom in a little bit, and you'll see that I've got my work plane. This is the RP lamp parts project. There's also some extra bits in here. The round shapes in Tinkercad are very low resolution, so I preloaded some higher resolution cone, cylinder, sphere here to have available to us. I also have some models over on this side of some of the parts that we'll be using and that will be fit to the parts that we'll be making. A dummy for the USB cable in, a dummy for the switch that will go inside, a little tray or carrier for the Arduino, a dummy of the Arduino, and a dummy of the NeoPixel circle that we'll use for lighting the thing up. Before we get started, there are a couple setup things we have to do, and then we'll build the basic cone shape and the ring that goes on top of that for the lamp. After that, we will put the Arduino tray into place. We will then add the opening for the USB cable to insert. We will put a hole in for the switch, and then the last step will be to put in some supports for the shade and finish up the ring part. Okay, first of all, for setup, we've got our project open here. We just want to make sure our grid is set up correctly. So down here we have edit grid. We want that set to millimeters. We want the work plane is here at the default of 200 by 200. That'll be fine. Or you could set it to your printer that you'll be using. The other item is the grid. We're in millimeters. We want to set this to 1 millimeter for now. That gives us some coarse movement control and snapping control, and we can obviously dial it down later if we want. So we want to make copies of some of these high resolution parts to work with and leave the originals in place. So what we'll do is copy the cone, controller command copy, controller command V. We'll make a copy of that. I generally assign the copy a different color just so I keep in mind what I'm working with. Same thing here, we'll make a copy of that and assign that a color other than white. And we're going to need to resize these. So let's put the cone in the middle. We're going to start really big with this cone. We can zoom in on that for a second. And then we'll be truncating it down to the size that we'll ultimately work with. So we have it in the middle of our work plane. To resize it, let's drag the ruler over, and that gives our dimensions. So we're going to make this 70 by 70 and 138 millimeters tall. So start big, but like I said, we're going to truncate it. So we're now at 138 millimeters. See, it's quite a large object for Tinkercad. Let's go ahead and while we're at it, do the same sort of thing with our cylinder. So we'll drag the ruler onto it. The cylinder we're going to start with at 50.7 by 50.7 by 8 millimeters tall. So 8 millimeters tall. All right, we can set that aside. Well, actually, let's go ahead and turn this cylinder into a ring, and then we'll work on the cone some more. So dismissing the ruler here, just for clarity's sake, zero in on that so it's nice and big on the screen. So we're going to hollow this out into a ring, and the way that generally do that is to make a slightly smaller hole and then group them together. So we will copy this and paste. So now we have a second copy of our cylinder. We will turn the copy into a hole. Now we may have to make this small enough so that the remainder ends up leaving the ring we want. So we'll put our ruler on it. We'll reset the dimensions here to 47.7. So we're going to create a 3 millimeter ring. 47.7. Now, in theory, if we align these together, that hole would perfectly cut out the center of that cylinder. However, since they're exactly the same height, sometimes it won't poke through on the top and the bottom. So it's not a bad idea. I'm just going to grab this and make it a couple millimeters taller and also drop it down a millimeter. So now I know for sure that these two, when they intersect, that hole is bigger than the ring. It's taller and it sits lower below the work plane so that it will actually punch all the way through. Rather than trying to line these up by eye, we're going to use the alignment tool to do that. I'm going to dismiss the ruler. So I select one, I shift, then select the other, and now I have them both selected. I go up to adjust align, center on X and Y, and now I know they're perfectly centered or aligned, and I can hit group, and it should group them, and we should have our ring. So we now have a ring that will fit the truncated cone once it's all finished. So that finishes our ring for now. We can set that aside, and we can go back into the cone. So we need to truncate an end off of this cone. Good way to do that is take a box, and we can use the built-in shapes here when we have right angles because we won't have a resolution problem with that. So we don't need to resort to a different copy of that. So the box we will resize using a ruler, and we'll make it 60 by 60 on length versus width. We will be extending it later, but we can do that to fit it to the cone. And we want to cut that cone, the small end of that cone off. So we'll go ahead and raise this up to be 38 millimeters off the work plane and turn it into a hole. I'm sorry, I made it 38 millimeters tall. We can leave that, but what I really wanted to do was raise it up 38 millimeters. Now, there we go. Now we have it raised up to 38 millimeters. And then we need to align these. So we can kind of roughly do it by hand, but then I'll go ahead and dismiss the ruler. Again, use the alignment tool, select both, adjust align, align them in X, align them in Y. Now they're perfectly aligned. Now I can go ahead and select my cube again and go ahead and make sure that it's going to completely cut the parts of the cone I don't want. So extend it all up till it's past the tip and you can't see the tip anymore outside of that box. Group the hole with the cone, and we'll get a truncated cone. Okay, and now we have our basic cone shape. We want to hollow this out, and just like the ring, the best way to do that is to create a slightly downsized copy, align them, group them, and you'll end up with a hollow cone. So we will copy this, we will paste this, move it out of the way a little bit, turn it into a hole. Now we have to resize it down to 64 by 64, and that will make about 3 millimeters per side a wall thickness on our resulting print. So let's make it 64 by 64, length versus width. Let me zoom in a little bit here. All right, so 64 versus 64. And to leave 3 millimeters at the bottom, what we need to do is raise it up. I could type it in down here, or I could use the manual lift key and just bring it up. Now I'm 3 millimeters off the work plane. So I can roughly line these up. I'll dismiss the ruler just for clarity. Select both of them, align them, and group them. Adjust align, align the X and the Y. Can't quite see the other one. Now they're both aligned. Hit group. And now we have hollowed out this cone shape, and we can kind of orbit around a little bit. And you can see that we've got a rather thin-walled base that we'll be using as the base of the lamp. And that gives us our hole. Now, in addition to using holes to cut things, another very useful feature of the hole is to use it as a semi-transparent shape. So we want to be able to see what's going on inside this cone, so we'll be putting a lot more parts inside of it. And so if we select the cone and turn it into a hole, now it's semi-transparent and we can have a better sense of what's going on in there. So next thing we want to do is put in this Arduino tray that the Arduino is going to sit in while it is being built. Again, we want to copy it, and I usually color these things. Make it blue. And we can roughly insert it. We want the inside of this tray, essentially the floor of the tray, to be approximately level with the floor of the cone. It doesn't have to be down to the tiniest amount, but approximately. We also want the front of the tray to be against the inside of the cone, but not protruding outside the cone. And we'll align it to make it nice and symmetrical. It might be useful to go ahead and set our grid settings down since we'll be doing some fine adjustments. So we'll put it down to 1/10 of a millimeter on the snap, which is the lowest possible setting that most consumer 3D printers will go to, so it's plenty precise enough. And we can go ahead and raise this up. So 3 millimeters up is about how far we have to go. It's actually a little less of that because of the thickness of the tray. But once you can see that it's just clearing the inside floor of the cone, you've got it high enough. And we'll go ahead and move it inside. You can see how the tips up here are beginning to stick into the inside wall of the cone, which is what we want. We can go ahead while we're at it and align this. So I've already selected the tray. We'll select the cone, adjust align. Now they're lined up. And we can orbit around and hold down the right mouse button. You can manually orbit. What we don't want to have happen is have this sticking so far forward that it sticks out beyond the wall of the cone. You can see that I've just done that. Zoom in a little bit. Now it's sticking out beyond there. Nor do we want it so far back that even if it doesn't stick out back of the cone, you have to insert the jack in so far. So again, where we want to end up is with the tips of this tray attached to the inside of the cone, but not sticking out front. I like to put it all the way up to the front, so a tiny bit. It's a tiny bit down, you can see it's sticking out, and then back it down so I'm sure it's inside. So that's where we want to be. Before we group these two, we need to change the cone back to a solid color, otherwise it will act as a cutting, which we don't want. So we'll select the cone, make it a solid color, then select the tray also with the Shift key and group them. And now we have a cone and a tray that are joined together. If we want, we could take our Arduino, stick it in there, get a good sense of how it's going to sit in there. It's sitting in the tray. It'll be a little higher than that because we didn't really raise it up. It's not sticking out the front of the cone, and that just gives us a chance to do a trial fit. So we have the tray in. The next thing is to make the opening for the USB cable. And the USB cable has this, zoom in on it for a second, has the little protruding jack on it. Then they generally have a square or rectangular molded plastic. We could just make a rectangular opening for this to go into, but what that means is the 3D printer would have to bridge this whole top gap over empty space. And that's something that 3D printers kind of struggle with. So what we'll do is we'll make this shape, but then we'll put a little arched roof on top, which will make it easier for a 3D printer to print the space, which will leave a small gap above the cable. So to do that, again, we'll select a box. And this box will end up making our primary hole with. We're going to put the ruler on it to resize it. Zoom in on that. So the box we want 12 millimeters wide, and we want it 9 millimeters high. We'll leave the length at 20 because that doesn't really matter for making a hole. And the next thing we're going to do is dismiss the ruler, but the next thing we're going to do is add the arch. So if we drag out the round roof shape, which is over here, we'll use this for our arch. It's not perfectly round, but its scale is going to be so small that it doesn't really matter that it's not a high precision part. We have to rotate this 90 degrees, If you pick the inside of the wheel, it gives you nice even rotation. So now it's lined up, right? We then have to resize it to the same size as our box. So let's put the ruler on there. Let's make it 12 millimeters wide. Let's make it fairly short at 3 millimeters. If your printer struggles to bridge this gap, you could make this taller. So we could put it a more rounded shape, but that will leave more a gap in the top of your hole for the USB cable. So we'll set it at 3. Now we need to put this on top of the box that we just dragged out. And there's several ways to do that. You could put a temporary work plane on the box and do that. We could lift it with the lift key. We type in the space. We know that the box we just created is 9 millimeters high, so if we set this 9 millimeters above the work plane, it'll be in the right position. Frankly, on something like this, I like to go a tiny bit under just so I know they'll line up and be one solid piece without any gaps. So I'm going to put it at 8.9. And then when I line these things up, there'll be no doubt that they will be fully joined. So we align that roughly over the top. We'll do the fine tuning with our alignment tool again. So select the top, select the bottom with the shift key down, align on X and Y. And we have them all lined up there, group it. And now we have this shape that sort of looks like a loaf of bread. And that shape will be a good compromise for something that's printable and at the same time will fit the jack relatively snugly. We raised the floor, inside floor of this cone is at 3 millimeters above the work plane. So we might as well bring this guy up to 3 millimeters above the work plane as well. You can do it manually or type it in. That way it'll line up with the inside of the cone. We're going to drill a hole with it, so we'll make it into a hole. And we're going to line it up with our Arduino tray. So if we align it by selecting both of these and just align it here, we should be good to go. And then we can move this in. Since we have the grid set all the way down to 1/10 of a millimeter, holding down the key will only move it slowly, which kind of drives the saving feature, autosave feature crazy, but it'll work. All right, so we're drilling in at about 3 millimeters, and we can zoom in on this part. And if we rotate inside the cone, you can see what's going on here. It's coming in right in the middle of the Arduino tray, sort of maybe slightly cutting into it, but that doesn't matter. And it's fully, you want to make sure this tip is fully inside the cone, so that shape, loaf of bread shape, is cutting all the way through the cone. That looks good. So we will select that. We will select the cone with the shift key. We'll group them, and we should have the hole we need. Okay, so now we have a hole going through there. We can check that fit. This is approximately maybe slightly oversized USB jack. So if we bring that up, sort of bring it up, it's already off the work plane, put it in. Yeah, it fits in there pretty nicely. If you want to look more precisely, we can turn it into a hole, move it around a little bit. It shows you exactly how much clearance you've got, but it seems like it's fitting pretty nicely, so we will put that shape back. And there we go. So the next thing we need to do is make a hole for the switch, which is a little bit simpler. This is a model of the switch. There are several parts to it. This thinnest cylinder is the shaft that presses up and down. The middle cylinder is the screw threads, and that's where we need to put the hole so it fits this middle cylinder. And then the back represents the body of the switch itself, and then there's a soldering point for the leads. So we want to make this hole. We can align this with the cone, just have everything nicely in a line and concentrate this stuff in the back. So we'll select them both, hit align. We want to mount it on the side of this cone, but we want to leave a little bit of shape, a little bit of space rather, between the top of this opening and the hole. If we put them too close together, the print might not be successful, and we're going to tilt this to match the slant on the cone, and the bottom where you solder the wires on the switch might actually impinge on your Arduino. So what I'd recommend is we leave about 6 millimeters between the bottom of the switch and the top of this. One step I wanted to do, but I didn't, was to make a copy of this and work with a copy rather than the original. So I'm going to go ahead and make a copy. We'll put the copy back, and since we already have this aligned, we will turn this into a hole. So we'll actually use this to cut our shape. If I cut with my one and only copy, when we make the cut, it would disappear, and I wouldn't have one to go back to without re-importing or getting it from somewhere else. Okay, it's aligned. So let's just go ahead and raise it up manually till it looks kind of good, and we'll move it in. We'll realign it just to make sure we got it. Remember, we want to go to the middle cylinder. How do we know it's 6 millimeters off there? And that's just a rough suggestion. What I would do is bring it down till it's touching the top of the USB cable. So this is 13.3. Let's call it 13.5. Plus 6 would be about 19.5. So let's bring it back up to about 19.5. Now the switch is currently in straight. The cone has a slant to it, and that's not the best idea. The nut, when you tighten it down on this, would not tighten down properly because it'll want to go follow the threads on the switch. It just won't seat properly, and it won't look very good. So what we want to do is tilt this switch, and you can kind of do it by eye. I can tell you it's approximately an 8-degree tilt. So if we select the switch, and this time we're going to go the outside of the wheel so we can tilt in 1-degree increments, bring it down to about 8. That's an 8-degree tilt. We can rotate around inside the cone, see what's going on. We can see that we've got a little bit of a problem here where the body of the switch is impinging on the inside of the cone. So we'll want to go ahead and bring that back. So the bottom of the switch is clear. We'll need to realign. We still have a hole. If it looks like a round hole and not an oval hole, looks pretty good. That means you got your tilt good, and you should be good to go. If you're off by a degree or so, it's not going to matter. You just don't want to go in there with a level hole. So let's go ahead and realign these. Select the switch, select the cone, align there, and we're ready to cut. So go ahead and group. Wait for it to clear. Okay, now we have our our hole for our switch. We could take the switch and test fit it, but we'll skip that step. So we're getting there. There's 2 more steps left. One is that we have to put in supports for the shade so it doesn't go all the way to the bottom of this. And then lastly, we have to put this ring on top, which will help keep the shade from falling from the outside. The supports we're going to put in are also there to mount the LED ring. So they serve really 2 functions. We'll use the cylinder for the supports, which we'll go ahead and do those next. We're going to need 4 of those. So let's make a copy of this to work with. To begin with, we'll use them as holes just for visibility purposes, but of course they'll eventually need to be solid colors. So the sizing on this, we want our cylinders to be a specific size. So we'll drag out the ruler on that. We'll make them 12 millimeters by 12 millimeters on the X and Y, 12 millimeters on a side, and then on our Z scale we want to make them 36 millimeters high. Okay, so there's no really special reason these have to be cylinders. They just are a little easier to manipulate that way. We'll dismiss the ruler. So we have 1. We need a total of 4. So we'll copy this and paste once, twice, 3 times. So now we have 4 cylinders currently as holes, and we need to move these inside the cone. This will be a little bit fiddly because we have to manually line one up. So we kind of want to go to the 4 corners since these are supports, but you can't have it so far out it's sticking outside the cone. On the other hand, you can't have it so far in that it's inside the Arduino tray because then the Arduino won't fit. So we'll sort of roughly put them in shape manually, and then we can sort of zoom in on each one and do some fine tuning here. I generally like to push it till they're sticking out and then back off. So this one you can see is impinging on the inside the Arduino tray a little bit. I still have my grid set to 1/10 of a millimeter, so now I'm going to back that down, and I can see that it's still a tiny bit inside. I like to make sure that all the shading there is gone. Now if I rotate around, I can see it's sticking out a little bit, so I'm using my keyboard commands, whoops, wrong one, to back it down just enough that it's no longer showing. That one probably is good, but there's a tiny wisp of a line that shows up there. Okay, so we're good on that one. This one, you know, again, we want to push them as far as possible into the corners to be good supports. So this one, we've got it inside the Arduino. Now we need to make sure that it's not sticking out of the cone, which it probably is, a little bit. It's hard to keep straight what these keyboard keys do as you shift around your piece. All right, so that one's close enough, I think. Yeah. We'll shift over to this one, zoom in on this one. This one's not very good. Again, we'll put it so it's just clearing the inside of the Arduino tray. There's no problem if it's overlapping the outside of the Arduino tray. There's not going to be anything out there, just on the inside that you need to watch out for. And this guy's going to have to come back quite a bit. So it's fully inside the outside of the cone. Again, it's not a problem if it's touching the inside of the, it's penetrating the inside wall of the cone. In fact, it helps hold everything in place. So it's fine here. You just don't want it showing on the outside. Now we can do our last one. I'll drag it around a little bit, then use the keyboard for some fine tuning. Let's check the outside placement. Stick out just a little bit. As you rotate around the 180 degrees, the direction your keys cause your part to move reverses, just like a remote control car when it comes back at you. So again, you might find yourself fumbling with those keys until you get the parts moving the direction you want them to. Now, none of my parts are protruding. Well, this one's slightly off. Doesn't hurt to make a second check there. None of my parts are protruding into the Arduino tray. They're not all perfectly aligned with each other, but that's not going to be a problem. If I orbit around the outside, none of them are sticking outside the cone. So they're all flat on the work plane, which is fine. So we're in good shape. Remember to set these back to a color before we group them. Otherwise, you will cut holes instead of make columns. All right, so we now have 4 columns. We'll make a select box around the whole thing. We'll group the whole thing. Wait for it to save the changes, and then we'll have a solid shape. Now this is all one piece, and we should print with no problems. The last step is to put this ring on, and the ring again provides an outside support for the shade. For the ring, we just need to raise it up and then align it and group it, and we're all set. So the ring, we can put the ruler on it. We could raise it up to 37.9 millimeters. So put it at 37.9, kind of roughly. I'm going to rehome this screen just because it's getting a bit tilty and disorienting there. So we've got it raised up. We kind of roughly have it in shape over the cone. We'll select the ring, select the cone, adjust align. We'll line it up on the X and the Y. We'll group it, and we're all set. They're both selected, hit group, and we should be good to go. Your printer might put a little bit of a seam there, but it shouldn't be a problem. Okay, so that is the completed lamp base. The last thing we could do is take any of these parts and try test fitting them, but we're going to go ahead and test fit this ring since I haven't used that for anything. We should bring that up to about the same 36, let's say. Shove it in there. We'll go ahead and for the moment just turn the whole thing into a whole so we can see this alignment. And you can see that you got some space there. There needs to be space between the outside of this ring and the inside of your cone so that the shade can go between them. But that ring is definitely going to fit. So you can do any remaining test fitting you like. Put the ring back, the cone back to a color, make it a nice light blue. And this is ready to print. This is all finished and ready to print. When you can save it by going into Design and Save, just remember when you go to download it that you want to select this first and download it just the selected part so that you don't end up printing all this other stuff. The other alternative, oops, selected my sphere there. The other alternative would be to delete all of these from your saved copy. But easier just to select the lamp if we're ready to print it, the lamp base, download for 3D printing, STL, and it says download selected shapes. And it tells us that we have one thing selected, and then when we hit STL, it will download just the part that we want to print. And that is it for making the base for the Rapid Prototyping Workshop class project example.